signals need to be in the embed. Why can't you just do the normal similarity search and then apply those as like pre-filters or post filters? Like we've got great mechanisms for doing that kind of stuff. Why bother putting it in vector?
Very good question. Almost feels like well, so when you think about the ways of dealing with metadata, right? So this is what we have been sort of doing, and it sort of works, right? Is you can filter your data using kind of SQL-like statements or whatever the underlying database offers. You can kind of constrain the search through the vectors with those other kind of more crude operations, right? You can say, when the user looks for a recent news about some topic, you can interpret the word recent as the filter, right? You can basically say, okay, show me all the news within the last 7 days, and then that will sort of filter the past through the index, and then all the results that fulfill that sort of predicate get ordered by the similarity of the news topic. The problem of this is basically there are kind of like two problems there, right? One is any kind of filter representation for kind of a goal that's actually not a step function, right? Will be arbitrary. Is it 7 days? Is it 8 days? You don't know, right? We can argue about like, can you binary search on the filter, right? But it gets complicated. So that's kind of part of the problem. And then even if somehow magically for a given topic, you figure out, okay, it is some kind of filter that maybe makes sense. Then still everything that passes you need to order by the vector, and you're sort of combining within your infrastructure this nearest neighbor searching vectors with the filtering, and that gets complicated for big indices, right? Because they're sort of combining two different index structures. And if you're a very big company, you can maybe build these systems completely from scratch and do all kinds of scoring in your shards and merging and complicated. But then that's where we actually work with that. And so by expressing all the signals of both the data and the expectations of the goals of the query in the vectors on the both sides, then you can just do cosine similarity, right, to navigate those trade-offs. Then it's this kind of way to standardize.
So, okay, I want to repeat it back to you in a different framing and see if you align with it. So is what you're kind of pushing on here sort of like the bitter lesson, but applied to the embedding space too? So instead of saying like, well, like we're going to train this really bespoke thing for like the core of the model, and then we're going to have all these other like extraneous pieces, but we're going to try to make those work in harmony. You're sort of bitter lessoning us and saying, no, put it all in the stupid model and let it handle everything.
All right. So that now talks to the model problem, right? So basically, yeah, like when we somehow make the leap and say, okay, let's express all our metadata into the vector, how do we do it, right? And that's a model like, so how do we train a model that can eat all these different signals? Some of it might be text, some it might be numbers, and so on. And it can produce a vector that somehow encodes all of this stuff, right? So that's a modeling problem. And yeah, you can kind of feature engineer all those signals and train an encoder that produces a vector that if you then use it for the downstream task, it performs well. Or if not, you propagate the error into the encoder and you kind of do all this work and eventually get somewhere, hopefully. And this is, by the way, done in kind of the big companies, right? Custom encoders, nobody's stringifying, big JSON files and adding them through a language encoder. It's custom. But then it's a big project. And often those vectors are kind of single purpose for that one given task. So, ideally you find some way to productize this, right? And our approach is, actually your data, even if it's a complex entity, is made out of a bunch of different properties of different types, right? Numbers and, timestamps and text and so on. And we are all very, we have the benefactors of people doing all kinds of encoders in the open source world, and they can encode these different kinds of data by themselves, right? And then for some of these properties, like the timestamp, you don't actually need a model to encode the timestamp in that way, and then it's like, there is some like caveats there, right? But that's sort of the approach that seems to make sense. That basically you somehow solve the encoding problem for each of your properties of the entity, for each signal independently, and then find a way to stitch those partial encodings into a customer vector or product in the e-commerce setting, the product vector or patient record vector, right? That somehow aggregates all these different signals and does it accurately. And is then kind of the basis for asking questions against the data set in a way that now the vector actually contains the different signals for you to be able to pull that out, and you don't have to kind of do filters. You don't have to do re-ranking as much. And, the problem of, we're probably drawing there. The problem of re-ranking is it only applies to a tiny fraction of your index, right? So if you have to resort to re-ranking, you are applying the scoring function to a tiny fraction of your index, and you don't actually want to do it, right? The only reason you would do it is that the function is too slow to run over your entire data set, right?
Yeah.
And so that there is this tension there that, like, if you can't express the scoring function by a vector that then does the similarity search, that's just better because it's evaluated versus the whole system.
Understood.
And then, you can do things for re-ranking to kind of refine around the edges.
Yeah.
But re-ranking alone is not going to solve the big problem.
Yeah, I do think there's always been this implicit dream of like, I only rewrite because I can't afford to run both in better. So like, yeah, and you did skip ahead to one of my questions, which is basically like, do you still see a lot of value in re-ranking and ranking stage for some of the like broader stack? And then get to the thing that I'm most excited about with regards to re-ranking is like, how do you improve the in this like,
So I think re-ranking for 80% of the cases would be just unnecessary complexity on top. And for 20%, maybe you actually need it. And the value of re-ranking comes from, you can run a more expensive model, right? Because if the underlying trade-off navigation system is the cosine similarity of two vectors, there is limit to what you can express in those like bits that get, matches. And so you can recite this on top, right? You can have multiple stages of doing that. It's so the improvement, right? Usually re-ranking is the place where feedback loops happen, right? So you can kind of have the index a bit more stable, and then you can train the re-ranking model using some, let's say, behavioral data, and that way you are converging to better results. And it feels kind of more lightweight because it doesn't happen in the underlying index, right? You can just retrain the ranking model and sort of benefit. But you are always kind of doing kind of half of the job because the sort of main line is driven by the what most people call candidate generation. And I think this is the part of the problem that we got used to just making shitty candidates and then squeezing some value out of them.
Sure. I mean, so you do it honestly. And I would be idiotic to not ask you about personalization. So like, if you don't care about the re-ranking, if you just care about candidate generation, making that better and better and better and better, well, what about those of us that care about, personalization?
So maybe personalization is really important, right? So all of these kind of people that exist, I also really believe that. And I think it's really important because we have actual users using our systems and they have goals, and I think we should try to understand what their goals are and what their preferences are, and we should help them achieve those goals, right? So if you don't model what the user probably wants to achieve, that's a huge missed opportunity and sort of basically you will fail, right, to deliver on those goals. So having some way to do it, I think is critical. And then it's a question of how much can you productize it? So broad range of systems can achieve those goals because normally recommender systems, 2-tower models and training from scratch. And, there actually hasn't been many products out there that actually productize that, right? There is the like Elastic or Algolia of Rexwitch, right? So
I know a couple of people trusting.
and people do because it's an important problem. So it's also like really hard. And it's really easy to, do bespoke models for clients and never really figure out how to productize the problem. And so I think this is like one area where re-ranking is helpful. There are ways to do it complementary, let's say, to re-ranking, which is you can try to figure out how to make a user vector, right? How to aggregate observations of what the user is doing, clicking on, and then you can aggregate those observations into a vector and use that to bias the search vector, right? You can sort of combine the embedding of the query with the encoding of, let's say, the items the user clicked on before, aggregate those two together, both personalized search. And then it's not quite as simple, but it's, that's kind of the
Yeah, a little bit of like step 4 profit in there, but yeah, understood. Okay, so the one thing that scares me about some of this vision is that like we are the benefactors of very powerful embeddings that are like only an API away, truly incredible deep models. And our collective understanding of those latent spaces is comically like truly baffling ignorance about what's going on in those latent spaces. And what you're now saying is we're going to make these latent spaces way more complicated, these encoders way more bespoke and non-intuitive. And frankly, we're going to try to cram way more intuition or vibes into these vectors. So you're taking a problem that we're not very good, and you're making it even harder.
So what's the problem?
Yeah, like help me sleep at night.
Yeah. So the one thing that I can hopefully say to help you is that when you apply these encoders to the different signals within your data, right? Everything you know about the customer, you have some encoder to encode what the email communication has been versus what they were clicking on versus what they are buying. You have 3 different encoders that help you represent it. Well, you slap another couple layers of a neural network behind them and try to fuse the results into something that's the opaque picture again, right? And then, okay, how do we make sense of that? Or you could just take the easy way out, and I'm an engineer, and the easy way out is, well, take their outputs, normalize them, and just concatenate them together to make a big vector, right? And this sounds super dumb, but one benefit of this is that, well, the encodings will stay separate, right? That you'll have the first 100 dimensions encoding some aspect of the data, and the next 100 dimensions encoding some other aspect of the data. And so at least on that level, that, okay, the patient record came back, it was the risk, the encoding of the risk aspect, or something that came through the imaging data, or something that came through the text data. You can at least entangle kind of one layer, right? If you keep them separate. And then, okay, once you look into the encoders themselves, you're kind of screwed, right?
YouTube Rex person that says simply concatenate the vectors. We're all shocked. Am I right? No. Yeah, okay.
And how are you evaluating? So what is the evaluation process? In traditional like it's typically like string map contains. What is some of the ways that?
Yeah, so that's a great question. I was trying to use more radical here. And I'll say that in the general purpose case, you can't define it. But for function calling and for structured operations, you can actually define hallucination, right? So what do I mean by that? If I were to, I'll send you $100, and I ask the LLM, how do I send $100 to my friend? And if the LLM tells me, use the PayPal API, it's accurate, right? But if the LLM tells me they use this PyTorch API, it's inaccurate, but it's also not hallucinated, right? Because I can actually send you money. Well, I can't send you money, excuse me, but if you call the API, you get something out of it. But if the LLM says use PCB API, then such an API does not exist, right? So you can define that as hallucination. So you can define it very precisely. And the way we do this is by using this classical concept in programming language literature called abstract syntax trees, right? So I get an API call. I ask the simple question, is this API call a proper subset of the set of API calls that a provider gives you? Now, the observation here is that given a snapshot in time, the set of APIs is fixed. Right? So today, if you use Stripe as a service, there's only a set of APIs that you can use. You can't will an API to existence, right? Across time, it can vary. That's okay. But given a snapshot in time, the set of APIs is fixed. So we ask the question, is it a part or is it a subset, the LLM-generated API, of the set of APIs the service provider gives you? And if so, then we say it's not hallucinated. Right, so that's a metric, and so abstract syntax tree is a metric. And there's a lot of discussion on recommendation systems, and you can think of abstract syntax tree as an offline metric, right? Like NDCG, discovered cumulative gains, so on and so forth. We also have an online metric, which in Nexus would be click-through rates, CTR, which we actually execute the API. So if you ask what's the stock price of Tesla on May 11th, 2023, then we call the Yahoo Finance API to actually measure the stock price of Tesla and see if that works or not. Right? So you can think of the user comment, and that's been a very common use case of Further, which we never expected. There's a bunch of folks coming asking, what's the spread on copper in this particular geography, right? And for some of them, you want to use Alpha Vantage, some of them Bloomberg, some of them Yahoo Finance, so on and so forth. And so for this, we actually deploy the API. So to summarize, the two metrics we use are abstract syntax string, which is very field dependent, right? So it gives you guarantees, right? It's not like LLM as a judge. It's consistent. There's very clear measurement metrics. There's very clear science behind it. It's just pre-traversal, right? And on the other side, there's proper execution, right? So you're having a whole bunch of diversity in the topics, Rapid API, Postman, what have you. And through these channels, we actually execute the different APIs and measure, do you get the response that you expect?
Interesting. So the downsides of using abstract syntax tree is like kind of need to have a kind of focus of API. So basically that reduces the ability for you to call any API. So
yeah, so that's a great point that you bring up. And so the short answer is yes, the corpus API exists. But the argument here, so there's two arguments here why this is not a concern, right? So the first is you have open sourced a bunch of tools, right? And so the tools you can either go top down, you can say, hey, I'm going to look at Chase Bank, I'm going to look at Stripe, Ideal, and try to build APIs, but that's not practical. So you go bottom up. Can we support every RESTful API call? Can we support every GraphQL call? So as long as you support the language, we can support any API that builds on top of it, right? So we have open source tools that support Python, SQL, JavaScript, REST, GraphQL, SQL, I already mentioned, but RESTful API calls, so on and so forth. So that part is done. But that's just the tool. Where do you get the data, right? So it's a very subtle point here. Unlike classical LLMs, right? So why is that a concern with data? Is because, I'm fishing to the car here, but if OpenAI reads from New York Times and you read what's dispute multiple times, and people are not happy with it. But with API calls, the incentives are very well aligned, right? So if LLM asks you to use Stripe API, you use Stripe, Stripe makes money, right? So if they recommend you to use an AWS API, you use AWS, they make money. So the incentives are so well aligned that a lot of service providers actually give you very well-structured data very easily, right? So open API specs, Swagger files, tutorials, and just very thorough JSON distribution. So for a lot of these providers, it is given to you across multiple domains. So yeah, it's, the incentives are aligned, so you get it very easily. And we have open source tools where you can actually build this up into an abstract syntax tree subtree. So yeah, there is some one-time cost, but that has already been paid. So it's reasonably straight now.
So are you mostly like going out to scrape these documents essentially?
Yeah. So when we started off, we did yes. Today we don't, right? So we have something called an API bank where different providers contribute APIs. Of course, you want to have like provenance to see there's no spam, and you want to occasionally make sure it's up to date, so on and so forth. So we have processes for that. By the way, I think today we support around 63,000 plus APIs across hyperscalers like AWS, GCP, Azure, finance providers, Stripe, Adyen, CRM tools like Salesforce, ServiceNow, Datadog, etc., machine learning API, etc. So it's user contributed.
So I'm curious if you think that the AI labs are treating on your function for it.
Oh, absolutely. Yeah. So there's two things happening, right? One is every time a model comes out, you get a pull request from someone from some of these frontier labs saying, hey, this evaluation is bad. And like, I think some folks support XML and not JSON. So then they're like, if it's a float, it's also okay to give it an int if it's 5.0, etc. So, and the good thing is all these discussions are public. So you can actually go and see what folks at Mistral want, what folks at Anthropic want, folks at OpenAI want, what folks at Databricks want, so on and so forth, right? So we are trying to keep it very open, right? So there's a lot of training that's going on. There's also a lot of, trying to nudge the leaders about what we are here, to have your models. But hopefully, what we can get is to be open, right? So if you have any concern, everyone can voice in, and then hopefully the right wins. And the other thing that helps us is as academics, we don't have a horse in the race right now. Like, oh, it's worked really bad to us, so we can slightly we can push them back a lot more, which we try to do a fair bit. Yeah, so there's been a lot of push and pull, I would say. And this might be a modern take, but I feel it's okay to train on training data, right? So why we not want to do this before is because your training data was, sparse. You're trying to deal with like ImageNet, CFARS, extremely small data sets, and you had a few rich analyzer, not grid memorizer now. But generally, if you're trying to have like 15 trillion tokens, right, which is way more than any of the data sets that most people think of, then it's okay. Well, that's a philosophical thing, right? But if you can train and still figure out a given intent and then be very faithful instruction followers, then it's okay. So that's one.
And you had like evals that give you it's splitting or based on
Yeah. So we do two things, right? One is as a very public eval set, and that's important to win credibility, because if I say I have a private data set, I'm not going to show you, but trust me, OpenAI is on top. It's all very helpful. So we have a public data set, and there's a few other things that we do, right? One is because we have a hosted endpoint, many people hit us. So we have this like Neo data sets that we want to use for evaluation, but it's slightly tricky, right? Oftentimes, if you get a batch from Hong Kong at you with internal data points, do you want to release them, right? So there's a little bit of that. And then there's a lot of science actually trying to look at complexity scores, and I try to see how well, how much, like, can you try to have a proxy of how much of it is that they use to train, right? Because you can see some models. Everyone has trained on the shared GPT data set, which is an OpenAI distiller, and you can see common crawl that your shared GPT data. So you can very easily make off. Yeah, so I think in science, right, if a model has tried to distill or train from another person's data set, you can tell it very easily. It's right. So yeah, I think people are aware of this, so they try to avoid it. But yeah,
the context is that the Claude 3.5 Sonnet, I think, went on the number one on AWS.
Yeah, and so I think there were Claude. I think initially was on top, and then OpenAI had an update checkpoints, and they went back, and then Claude's gone back now, which I think is reasonably sad. Right, so when we evaluate these models, we don't document them, right? So it's commercial endpoint. We don't take any special endpoints. It's one endpoint you get. It's registered in the name of UC Berkeley. We take these endpoints, and all the scripts are also public, so you can also recreate it. What we do is like we try to also give you additional metrics to like P95 latencies, P90 latencies, because oftentimes people don't talk about this. And there's this concept of, in an LLM, if it's doing 400 tokens per minute, that's okay because that's how much humans can read. That's true, but keep in mind, if you're using LLMs in agentic systems, your bar is not humans, right? You want to do much quicker. If someone asks you, how do I play this game, or how do I book this flight? You want to do multiple agentic calls, do multiple interactions, and then go back to the user. So just 400 tokens is not enough, right? So quicker is always better. So we also try to measure P50s, P90s, and also the concept of cost, right? If you're giving a service, you should at least make UN. So we also, and a lot of this is actually user contributed. Like as a startup, I would never know why do we care about cost, right? But when people come back and say, look, how does this model vary with other when it comes to cost? So we also try to include that.
Speaking of cost, do you want to give us some understanding, like let's say you run Gorilla, the API model on their own the server with enable with GPU, how much roughly that would pump?
Yeah, absolutely. So the context is we have something called the Open Functions 3.2, which is an open source trade model for trade license on function calling. And so the cost is a pretty tricky thing because today, most people, it's shocking, still do batch size one inference. Right? So batch size one inference means that given a data point, you don't wait to collate it, you quickly run to completion. So you're underutilizing your GPUs. But here you can say, okay, can I try to bulk it up, etc., if you have volume, so on and so forth. But roughly you can say, if you want to take retail rates, right, 8 V100s today cost about 20K USD on AWS, not reserved. You could probably run, I would say, if you do the math, it comes down to, it costs you about $1 to do about 2,000 API calls with very small batch sizes. So you can play this around, you can play around. But I think 2,000 API calls to the dollar is reasonably good. And keep in mind, so LLM's cost may increase or decrease, but think in terms of capacity, right, or capabilities. So GPT 3.5, if you think of that as capability, the cost of any fixed function capability always goes down. right? The capability itself may improve from 3.5 megabit to 4, and there might be a step function increase in cost. But here's GPT-4, the cost is always going to go down, right? What's that? 8B is the new 30B, something like that. So, right, so cost is always going to go down for a given functionality. And so a lot of people are actually not that concerned.
What's for you next? Questions on your research.
Yeah. So there's a few interesting things that we want to do, right? So today, reasoning for LLMs and trying to integrate that into your workflows, most people can do that well. What I think is still missing is two things, right? One is who's going to build, in some sense, like I don't want to say OS because that's very loaded, but like who's going to build a runtime for executing and interacting with your LLMs? If you think of a user at LLM and the digital world, there's a whole cottage industry of tools that helps you augment the prompt between the user and the LLM, right? So this could be a RAG-based things, index lag training, there's or having a whole bunch of tools that help you do this. But when an LLM gives you an output, what next? There's no tool that helps you do this today, right? So yes, I say some look, so I will be more respectful here. What you want to do is try to can you build this runtime, right? This runtime, what should it have? Can it have atomicity? You want the LLM to do something, does something, you either accept the commit or you say, go back and give me the clean slate. Right? So can we have this atomic sort of roadmaps? And the second is, like I said, can I give blast radius confinements? Can you say, look, I'm a manager at my enterprise. My customers are going to use this LLM agentic system, our workflow or have. Can I say every time this agent operates, it should not cost me more than $5 in value? Now, can you take this $5 as a cost and then try to enforce policies of what an LLM can do or cannot be? That's how you do this translation. And the third is simple undo semantics. Like, can I give you an undo button? Right, you use an API to update your forwarding table of a Cisco router. Can I give you a quick undo so that you can undo that forwarding table update? Right? Oftentimes you send a Slack message, or an agent sends a Slack message on your behalf. Siri sends a Slack message on your behalf with your iPhone. Can you press a button to undo it? Yes. For an email, you can't undo, right? So then can you have blast radius confinements? Email only the people who report to me, not to my skip or so on and so forth. So how do you take general purpose definitions and convert that into semantics that an LLM can actually enforce? And how do you do this in a more scalable fashion? I think it's pretty interesting.
We're going to talk about evals. I think everyone here is probably already aware of why they matter. So we're going to skip some of the preface around should you need them? But I'm going to assume that as no, right? Right. So, Russ has been doing this for a while. And so to set some context, what are your thoughts on active work for integration? And what should modern LLM application developers learn from that?
Okay, so I guess there's a lot of context in that question. So maybe I could back up and write background. So before I was working on Human Loop, where we're kind of doing prompt evaluation or management or error shoot stuff, I did a bunch of research, and part of that research was done on active learning to do with. So active learning is when you're trying to train a machine learning model, what data should I include in the training set? Mostly, so, and when people are labeling data, which data points are worth bothering to label. So if you're getting a human to label a piece of data, that's an expensive thing to do. Not every data point is created equal. If your model already understands something perfectly well, then why would you label that again? You want to go label stuff that model that you can learn from. So I did a bunch of research on that during my PhD, and it also ended up being some of the first stuff that we worked on when we started Human Loop. That's traditional active learning, but you can use a similar concept when it comes to doing evaluation. So when you are trying to evaluate a model, if you think about a very simple model, so not just an LM, but say we're just doing binary classification or something like this, or I just got a multi-class classification, I'm going to get a label test set, train a model on it, and then I'm going to calculate a bunch of metrics on that test set, F1, precision, recall, accuracy, whatever it might be. And every time I get a label, I'm thinking whether it comes from a model or human, whatever, labels are expensive. So you're always going to want to try and minimize how much you have to spend to get this test set. And you might ask the same question, okay, if I label it random, then there are things in my test set that might be super underrepresented. So there might be classes that only show up 1 in 10,000 times. And so in order to see just one instance of that, if I'm going to take random examples from a test set, I'm going to have to label at least 10,000 examples. And I don't want just one, because that's going to be useless as a way of measuring how good I am at that class. And so that's going to become expensive really quickly. So then you might ask yourself, well, hey, this thing works in training, active learning. Like, can we do something similar for testing? And you would say, well, I'll oversample the underperforming classes. Well, how do you do that? So the thing that we figured out was that if you have if you have a model that you want to evaluate, you already have the model, which is usually not the case when people are building test sets, right? Usually people build a test set up front. But let's say you have your model. Well, then you can do is you could get the models labeled across a large section of unlabeled data and use that to overweight places where the model thinks it's a particular class. Well, okay, you're going to say to me, but hold on a second. Like, now you've got a biased sample of your test set. Isn't the whole point of a test that it's supposed to be measuring how well the model generalizes? And now you've got to like label the test set in a way that uses the model, like having everything up.
No, the goal of a test set is to get your model closer to your objective.
Yeah. And so I would say there's two things to that. One, right, which is like, well, no, maybe you just care about like how good is the model at this particular class, right? It doesn't matter whether you're getting the overall performance of the model, but also you can actually still get unbiased estimates, or at least consistent estimates for most metrics you care about. So you can actually go and take a pre-trained model, do this thing where you're going to label of your unlabeled data, use that to select which ones you bother to actually include in your test set, and then still get a good estimate for most metrics you care about, F1, precision, recall, etc. The ones that are ratios of things, you can't get an unbiased estimate, but you can get a consistent one, and it's good. And we benchmarked this against like doing random labeling, and we benchmarked it against doing like other smart things you want to do, and like it definitely works. So yes, I think like it's something that people should look into. I think it's non-trivial to set up for yourself.
So tell me, like, I'm building Tolstoy bot, and I want to know, are the generations from Tolstoy bot, are they Tolstoy-like? How do I use this type of thinking to make great evaluations for Tolstoy? How do I take the first set of evaluations that I built for Tolstoy bot and make them better through something else?
Interesting question. I've not thought about it in this context. So
you mostly focus on like Rooster.
Exactly. I guess when it comes to like constructing your test set, right? Or when you come to do evaluation, you're really thinking about two things, right? One is I want to build a family of evaluators, which in aggregate give me a sense of how well this thing will actually perform for my research. And that's the point you were making a moment ago, which is like, compared to academic evaluation or the eval that people will see, every time a new model comes out and everyone talks about like evals and benchmarks and LM system, and no one in practice, that's not what matters, right? In practice, all you care about is like, how good is this at the thing that I'm actually trying to use the model for? And so you can build evaluations and test sets that are going to be more unique or more appropriate to your use states. And then I guess the question becomes, okay, I have things about questions about Tolstoy or whatever it is. Like, which ones do I bother including in my test set? And what you want is you want to cover well all the things that are likely to come up in production frequently. And so that distribution, that bias distribution that you're going to use to get your test set could come from a variety of places. It could come in the way that I described before from your model's predictions, if you're really just trying to like understand the model. But it could also come from like estimates of what is the actual distribution that you have from your users. So you might actually look at a model and like say, okay, what is the distribution of questions I'm getting? I'm going to use that to guide how I build my test set. And in each case, all you have to do is be like smart about how you sample the test set. So you're going to be doing like a weighted sampling, a concordant sampling, a really something like this to still get unbiased estimates of the metrics you care about, even though you didn't label at random when you're building your test set. So the intuition is pretty simple, actually, which is just like, I want examples of the kinds of things that are going to show up in practice in my test set. And if I do it at random, it's going to be very hard to get.
Yeah. And so to take that like one step further, it's not sample at random. It's sample where I think not only are there more cases coming from fraud, but also like scarier things, right?
Okay. Yeah. Like build a biased test set. It's, I guess, the principle of like active testing. But if you're going to build a biased test set, still calculate unbiased test split.
Yeah. I sometimes say that like if my evaluation swing is close to 100%, then it's useless. But, yeah, I think it's similar motivation. I want to read a quote. So rapidly incorporating new data into existing deep learning models or explicitly incorporating prior knowledge remain an open question. This is, of course, from his thesis. And so I'm curious.
And so Brian's now one of like 4 people who've read my PhD.
Yeah, a rarefied group. But my question is like, with fine tuning and RAG and React, can you feel like that's less open than it used to be? I could reread the quote.
Yeah, so don't everybody writes it. I do remember writing it. It's definitely less open than it used to be, right? So it's like it all feels like ancient history then, right? So I did my PhD thesis, like I finished it only like 2 or 3 years ago. But at the time that I started my PhD thesis, this question of like, I mean, at the time I started, even like fine tuning for vision models was still like ahead of us, right? So there's either like, how do I take a pre-trained neural network that's good at one thing and like incorporate new data such that it's good, it's good at something new. That was like completely unsolved. This is kind of why LLMs are so exciting, right? Like the whole reason why like I set up the first time I interacted with an LLM, and it's in the title of the GPT-3 paper, is in context learning, right? So it's partial about it. Like it's partially solved, but like I still have a cutoff on my model. There's still a date where I'm still doing RAG. The way that if I interact with ChatGPT, there's a memory system now, and the memory system is like hard-coded strings as far as I can tell. Like it's not, we don't have continual learning. So like it's better than it was. Like we've got, but also a lot of these things feel like kind of hacks around it, right? Like let's shove more things in the context, etc. I don't think we have like we don't have a solution to continual learning for sure. And that's kind of what I was trying to get at there.
Right.
But it's a lot better than it.
Right. I think of all 3 of these paradigms, though, even though they are hacks and gettables, I do wonder, though, in what degree are they like close enough to what we care about anyway? Because like presumably the reason that you care about like continuing is if you want some confidence that as you continue to use the system, as you continue to put more calories into it, you're going to get more like confident results out. And I do feel like all of these hacks get us closer. Do you feel skeptical they're upper bound? Do you feel like these are marginal? Yeah, like what's the glory that you see that we have in the learning?
I think people will continue to argue about like to what extent can LLMs like generalize to new things and learn new tasks, right? I think François Chollet has been going around doing the rounds because our evals this week. And it definitely feels like these are good ways of maxing out the capabilities of the existing models we have. Like every time a new model comes out, there's like a period of definitely like capabilities overhang almost, right? Like it takes ages for people to figure out how like GPT-3, it turned out was like very, very useful, right? Like we could have fine-tuned it for ChatGPT much sooner, but someone hadn't figured out that was like a good UX flow. I feel like we're maxing out the capabilities of what we're not doing. Like to me, like what continual learning requires is the ability for the models to learn to do new things in new contexts. Yeah. And I don't think we're going to get that through better RAG or better utilization.
Another important is the research is a lot better than I expected. You commented that like how many years ago did I say? I think 2 or 3. I think. But like you made this comment about like sort of like we have a huge way to go in NLP for reading and reasoning like a human would. And one thing that really jumped out at me about this, like, this statement is like a human. Now that we are in this epoch of like usefulness, do you care anymore that it's not the way a human would?
It's like what you said before about eval, right? It depends on your objective. I started this as a scientist. I still care about understanding things. I'm still very curious about how do humans do these things. So to a certain extent, yes, I care. But I'm also now running a company. And so like if you ask me about do I care whether it's done the way a human does it, but whether solving a practical task, not really. I do think that one of the huge breakthroughs of like Instruct GPT was taking something that like had within it lots of like capability and making it seem more human-like and therefore easier to interact with. So like, I don't think the thing needs to be literally doing it the way that humans do it under the hood. Okay. But I think it's superficially, it behaves in a human-like way, or at least like humans can reason about how it's going to behave. That's very helpful for interaction with the system. But I often wonder, like the neural networks that we had before that we were training on image generation or whatever it is that came before LLM, like how much capability was in there that we weren't able to actually leverage, because the only way we had of interacting with these things was like sampling the logics on the final layer. Whereas like we interact with ChatGPT by feeding this embedding tokens. It just so happens that we know how to reason up each embedding tokens to feed it because we trained it to be good at understanding language. And like, I don't know how to feed like embeddings to concepts, but maybe there's cool things I could do too if I did not make it there.
Yeah. Pivoting over to maybe what you were expecting. Who should write emails?
Okay, that is closer to which in ballpark what I was expecting. So, for context, we didn't do introductions. And so, like, why should I have opinions about this? I used to be a researcher, but now we help people do like prompt engineering and iteration and evals. We've done this now in practice at like quite a few different companies. And one of the things that I've come up with most strongly is that domain experts and product managers and people who are close to the end use space should be much, much, much more deeply involved, both in prompt engineering and in doing evals that has traditionally been the case. There's, I think historically, like a product manager thinks out a spec and then you have handover layer and like engineers implement. We just don't need to do that to the same extent anymore. Like people can be much more directly involved because they can write things in natural language, they can prompt, they can look at the outputs and have a sense of what good looks like. And in some senses, like writing your evals is writing the spec. Like you're saying, like, what does good look like? What is the objective that I'm trying to get for my users? And so it makes sense that that should be a collaboration between the people who are closest to the subject matter, closest to the end use case. So some concrete examples. One of our customers is Duolingo. Duolingo builds both chatbot and internal learning assistants. Like the only people at Duolingo who are allowed to prompt are the linguists, and they're also the ones who are driving evaluation. So there are machine learning people who work with them, and they have like obviously expert AI teams, but to a much greater degree than you might expect, like it is the linguists themselves who are like setting these things up. And obviously that requires having good support from people who are expert in evaluation and having the tooling. We've got companies like Vanta or FileByte who are doing stuff in the legal space. And again, like an engineer is not going to know how to write down an evaluation that looks at, a contract red line and says like, was this good or not? There's some things that they can concretely measure, latency, cost, accuracy on a test set or whatever. But there's a lot of subtlety and like task specific evaluations that can only really be done by someone who's domain expertise. So in general, like, product managers, subject matter experts, like should be, if not driving it, but at least like maybe really involved in creating growth.
So the idea here is that sort of the expert is the ultimate like arbiter for what is good data and what's good output. I would say the ultimate arbiters are user. So where you can like actually get concrete feedback data from end use spaces, like use it. It's useful for monitoring. So like the first thing we ever built was like being able to like log feedback from production and enrich your logging with it. But obviously you don't get that shit development. You don't really want to rely on that. You can't be something that's directing the wait for it. So before, like short of having your users, yes.
Yeah.
Yeah, I mean, as much as you're interested in keeping human education in recovery or something. So my last question for you is, you're old and we need levels. What has stood the test of time? What are the things that you thought about like 2 or 3 years ago in terms of like evaluating these systems that you're like, that is absolutely still what I believe? And what should those people that are kind of new to thinking about these problems learn when you're reading them?
So I guess it depends on how new you are. So I'm going to say some things that like will be extraordinarily obvious first, but I've seen people not do them. But so it's almost like a disclaimer, like just in case. So held out test sets are still really important. Like, and the caveat previous speaker, like, okay, if what you're trying to do is generate API, I agree. But like if you're trying to measure, will this generalize to production and you've trained on your test set, like you don't know. But that is still like remarkably often not done. So the first thing is like still use the held out test set and like a genuinely held out test set. So have a dev set too, because if you're like tweaking things and then getting your held out score and then tweaking things again, it's not a test set. So really basic fundamental stuff that I think it's easy to forget. Or so like I think because we have a new generation of people kind of coming into LLM who have come up from traditional machine learning or data science, that's definitely something I've seen missed. Making evaluations. I guess the thing that's changed for me, like what learns, like I went from being like someone who was in academia to someone who's much more in industry. And in academia, you're evaluating systems like in their generality in an abstract way. You want to know like how good is this model in general? And in industry, you just care a lot more about how good is it for this specific thing. So, I mean, this is why like active learning is actually less good for industry than it might be for academia in some senses at training time, because the premise of like that, or sorry, why it's better in industry than it would be for academia, because in academia, you build a data set like occasionally and then you use it for a really long time. Whereas like in industry, data sets were stale much more quickly, test sets were stale much more quickly too. So it's completely fine to like couple your model to your test set, or it's completely fine to couple your model to your training set, which you would never do if you're in academia. So I guess maybe they're not things that have changed for the world, but certainly like my perspective is that if you're doing evaluations in industry, then like benchmarks, public benchmarks matter less, academic benchmarks matter a lot less. Like you have to be going and evaluating this thing or a lot of evals that are specific to your use case and make sense in that context. Other than cost and latency and some other.
Say this one. You're talking about it a little bit with like this like execution of like these endpoints and like on a sort of like explicit way that is easier. I think in Hex, we've got a whole lot of problems that we have to like build evals to try to go after. And I find that a lot of people claim that their problems are more difficult or super down. You've seen a pretty broad spectrum of like problems. Do you feel like there's for everybody's problems just as hard as one another, or do you feel like people do have? I think like I think people are cycled upwards. Like I do think that there's a lot of they just care about different things, right? So like if you're Duolingo, you care whether or not the vocabulary is like at the right level for the person that you're speaking to. So you're going to have an eval for that. That's a really specific eval. So it's not, like why would anyone else care about that particular eval? Is the model using vocabulary that like for the TEFL level is like at the appropriate standard? I don't know. Or you're generating some particular, I don't know, we have people who are like generating documents for patent applications. They have to follow like a very mandated structure. So they have an evaluation that like has a binary classifier for each of the things that has to be included. Or one of our customers generates job descriptions, and different states have different laws on whether or not you have to legally show a salary range. And so like if the state says you have to have a salary range, they want to check that. So they have a binary classifier that like does that, an evaluation. Why on earth would anybody else build that evaluation? So yeah, I actually think they end up being like very specific. And so your medicine for that is to just build as much of the equipment to make it easy to do as opposed to try to.
But this is one of the places where the fact that you could do in-context prompting or LLM becomes super powerful, because a product manager could come in, get prompted LLM, get see some of the outputs, get generate a data set, and then you can fine-tune a classifier that's good at evaluator, but building the data set for it and like doing the initial construction of this bespoke classifier becomes something that's very low cost and very easy to do. So, I actually have like a lot of optimism about how LLM is judged, just if used appropriate.
What is using it appropriate?
Or it's not. So, yeah, that's a great question. I think that the mistake is like to chuck in lots of complicated subjective judgments into the model. So like asking it multiple things simultaneously and asking it to like output a numeric score or something like that, where it basically relying on the model's judgment quote unquote is kind of the mistake. If you ask it like to do objective information extraction or classification or things like that, then one, you can evaluate the evaluator in a rigorous way. And two, LLMs is really good at like, or they're much better at that, right? Like was X mentioned in this paragraph as a binary classifier? GPT-4 is great. Like can do that really well. Do you think that the writing was good on a scale of 1 to 10? Like that's a sucky eval, right? Because what does that even mean? Yeah. So if you can like create, I think you and I talked about this once before, and if you can create like evaluations that are each measuring like an individual thing that you care about, not mixing together multiple things simultaneously, if the evaluation actually can be answered sort of somewhat objectively by a human, so maybe there's still something subjective you care about, but you can break that down into as many like a family of like more objectively measurable things, and then we still like everyone still uses some amount of human eval. So like there's no antidote to like getting rid of human labeling completely, but you can scale it and you can have it in production if you augment it with model based. So like